I'm Scott Simi, Chief of Content with InDro Robotics, and I'm joined today by our Head of R&D Sales, Luke Corbeth. Welcome, Luke.
Thanks for having me again, Scott.
All right, today we're going to talk about one of your very favorite topics, which is robots. Does that work for you, Luke?
Who doesn't like chatting about robots? Let's do it.
All right. So there are a lot of different robots out there in a lot of different form factors. So let's start by you just listing kind of the most common form factors available.
Absolutely. So first and foremost, the most common one you'll see is a wheeled robot or a UGV, unmanned ground vehicle. There's a few different locomotion methods there between differential steering, Ackermann steering, and omnidirectional. In addition to that, there are tracked systems as well. Bipedal robots, quadrupeds with wheels, and humanoids as well.
That's a lot of options. Now let's set sensors aside, as those can be customized depending on what data you need to capture, and focus on the form factors themselves. So let's start with wheeled, bearing in mind that wheels can be for both indoor and outdoor surfaces. What applications is this form factor especially suited to?
Yeah, so there's a few different factors at play, right? The wheels can either be smooth or have treads. Obviously, the smoother wheels tend to operate better in indoor environments, while the treads improve outdoor performance. For a differential steering wheeled robot, I would say those are generally all-purpose. Ideally, something that can operate both indoors and outdoors under a variety of different conditions and applications. For the Ackermann steering, obviously you sacrifice a bit of mobility, but you get superior stability and longer range, meaning they're typically better suited for outdoor applications. And then lastly, you have the omnidirectional. Now, if it's a mecanum wheel style robot, it has to be used indoors. But for a true omnidirectional drive robot, it's mainly indoors when there's close quarters movement required and high maneuverability requirements. But they can also operate in light outdoor conditions as well.
And then there's tracked, those kind of tank-like treads. When are those a good fit?
Well, when it comes to treads, it's all about traction. So these systems are best deployed in muddy, sandy type environments where the conditions are very challenging to get around, and you really value that improved traction. They also do quite a bit better on some steeper slopes.
Gotcha. Now, bipedal robots, and here we're talking strictly two-legged robots that do not have arms and do not really have a human form factor. Who's using these and for what?
Yeah, the bipedal design obviously offers slightly less balance. If it's walking, there's only ever one point of contact with the ground. Typically, these robots, though, have a foot pad option, a full foot option, and wheeled options there as well. Truthfully, they're used more in research applications for improving this kind of locomotion. There's slightly less industrial viability. But relative to something like a quadruped, it doesn't need to operate as many motors. So sometimes you can get longer battery life out of these sort of systems.
Now, quadrupeds, everybody calls them the dog robot, is a form that gets a lot of attention. What use cases are these good for, bearing in mind that InDro can customize them, and indeed all robots, with sensor suites, autonomy stacks, and InDro controller for remote teleoperation?
Yeah, the name of the game with the robot dogs is stairs. If you need to do any kind of multi-level inspection, it's one of the only form factors that can reliably get up and down stairs, albeit it's still a challenge. But they're also really good in dynamic terrains. If you think something like a construction site that might have a lot of debris or unsmooth surfaces. They also can tend to excel off-road as well. So if you're going through a forest or a trail, you may want this kind of movement mode, mainly because it just offers more suspension, if you will. The legs almost act as improved suspension for these systems to get around really demanding scenarios.
Now, I saw a video you posted recently of a quadruped that also had wheels, so it could walk like a dog, it could climb stairs and go over obstacles, but also had the advantage of speed over a standard quadruped. Tell us about those.
Personally, I'm very bullish on the wheeled light quadrupeds. I would maybe go as far as saying that, this is the optimal form factor for virtually any application. The wheeled legs offer, as you mentioned, higher speed. They keep payloads much more stable while in movement, which is great for things like security applications or data capture. And they just offer best in class climbing ability as well. This is a really exciting development for the space, and I'm constantly looking at which option suits our clients' needs the best, and this one seems to be coming to the top of the list in almost every discussion these days.
Yeah, they're very impressive. And then we get to humanoids. These are the robots that are bipedal, have a torso and arms, and generally some sort of hand-like manipulator, and generally have a human form factor. What are the use cases and the advantages of these?
Yeah, so obviously a lot of overlap here with the bipedal style systems, but with the torso and the arms, it means that these robots can accommodate to existing infrastructure, right? The arms tend to be at an effective manipulation height of a person that would operate in those spaces today. It's not necessarily the most effective means of getting around, but being able to make very small, fine adjustments in every direction is helpful for when the robot needs to physically interact with an environment as part of the use case.
And I would assume, I'm just kind of throwing this out there, that because they're sort of the same shape and have similar movements to human beings, that really we wouldn't require any infrastructure changes if they were, for example, put to work in a factory setting. Is that a fair assumption?
Absolutely. And that's one of the reasons the total addressable market for these systems is so high, because in theory, as they continue along their development journey here and are able to do more and more tasks, they can kind of be plug and play in such a wide range of applications across manufacturing and even in the home, possibly one day.
Now, InDro modifies all of the above based on client needs, but we also design and build one-off or multiple robots, sometimes as a new production model, sometimes for specific customer applications. Our Sentinel inspection robot comes to mind. What's the advantage of a custom build?
Yeah, here at InDro, we don't really believe that there's a one size fits all robot. We believe that the robot should be outfitted for each specific application and objective. We've gone over the various platform options here, and platform is determined by the optimal way to get around the environment it will be deployed in. But from there, we can customize payloads for the data that needs to be captured. That could be things like HD cameras, thermal cameras, radiometric thermal, other things like acoustic, two-way audio, 360 cameras, and LiDAR, for example. And then from there, we really want to customize it even further to achieve the desired workflow that the client's going for. So if they want no human in the loop, then the system's going to need wireless charging. If they just need teleoperation and not full autonomy, it doesn't make sense to include all of the sensors that are needed for autonomy. We can lower the total cost of the system. So this modular approach really allows us to meet each objective for each application and tackle as many verticals as we do today.
Finally, I think it's worth mentioning that InDro can take any form factor, and with the addition of our InDro Cortex brain box, InDro's autonomy stack, and InDro controller, we can vastly expand and customize really any platform for any client. Is that a fair statement to make?
Absolutely, Scott. And I'm a true believer that we need to try to create some homogeneity in the user experience when it comes to robotics. If you think of something like DJI drones, for instance, there's so many different variations, but if you've flown one, it's very intuitive to fly the next, even if the form factor is slightly different. We envision a similar future and outcome for robotics, and that's what InDro Cortex, our autonomy stack and InDro controller are trying to create. We're trying to make them easier to use regardless of how they look or what data they collect.
Awesome. Anything else you'd like to add, Luke?
Yeah, I just think that our modular approach is the best way to tackle, any kind of research or real world application. So it's always exciting to be on the lookout for what compelling problems either researchers or businesses are trying to solve, and being really creative and crafty and leveraging our expertise and resources at our disposal to solve those problems. So it's an exciting space to be in right now, Scott.
All right, Luke Corbeth, head of R&D sales for InDro Robotics. Thank you so much for your time. It's always a pleasure to speak with you.
The pleasure is mine.